Alright guys, welcome to video number 11 of the playground project, and as we start getting into the final assembly. So we're going to start off with some notes about the assembly document itself. So we've been kind of working our way through this with the subassemblies of the different main components, and while we've largely been able to follow those instructions, we're getting to a point where the assembly process for the final portion in OnShape is going to be a little bit different than what we've used with Inventor. Some of the commands are a little bit different. You've probably recognized that. Some of the order of operations may have changed a little bit. So again, I'm doing my best to be able to go ahead and use OnShape for the final assembly. And I'm still going to keep the document up because it does provide us with details like the offset distances and the general layouts that we need to follow. So even though the constraints may not be the same, the general process will. So just be mindful of that as we move forward. So as you can see, I've already done one run, and it does take some time. I think one of the things that I'm not a big fan of in OnShape or Fusion 360 compared to Inventor is the assembly process is a little bit more finicky. It's a little bit more problematic. So as you can see, we've been able to go ahead and do the full layout. We've got the Crayon Pulls, all of the pieces are pretty much locked in place, but we're going to try and cover what needs to happen for that to go ahead and make progress. So I've already started an empty document for the final assembly for this video. We're going to go ahead and start adding in our parts. So remember that we're going to go into the playground project, grab the sub-platform assembly, place it, right click, fix it in place, and then we're going to step back and grab the wall subassembly to go ahead and place that component next. Now we'll add other subassemblies as we proceed forward, but this goes ahead and gives us a good starting point. So the first constraints that I think I'm going to use are mostly going to be the Planar Mates. So we can grab the top section and go ahead and line it up with the platform. So solve the problem, check your orientations. Sometimes you can flip it around, it's going to move things for you. I'm going to go ahead and start setting it up so it's going to be easier for us to proceed forward. So we solve, it rearranges some of the other sub-assembled pieces, and then we can go ahead and say that I need the back of that platform to be flush, or at least joined up to that edge of the platform. So let's see if we can solve it. It goes ahead and rearranges a little bit, and let's see, we're not quite there. Okay, actually, are we? Yeah, that looks like it's pretty much set up. Okay. So go back to our primary home view. We'll go ahead and close that up. One of those things to go ahead and make sure that you're kind of checking is click and drag and see how you can move the part. In this case, we were able to move the part, so we're actually not quite finished. Okay. So one more planar mate. We've talked before, ideally with your planars, with all of your constraints, you're usually having to deal with all three directions. Okay. So let's see if we can solve this, have it work out. That's looking good. We can now escape out of that, click and drag, and that is now fully constrained. Okay. So get back to our home view. We'll go ahead and save this because, as I've mentioned, there's a there are problems just with these assemblies. So make sure you have a point where if it really goes wrong, you can go ahead, escape out, you can not save it, you can go back to the previous versions. The history that they provide us with is going to be really useful when you have those issues pop up. So rather than having to undo or just start over from scratch, you're able to go ahead and step back to it where you knew it was working. So with the wall taken care of, let's go ahead and step into grabbing the next piece. So out of the playground project, let's go ahead and grab the monkey bar assembly. And and we'll place it. And we're going to repeat the process much the same way we did with the wall, except there's going to be a little difference in terms of getting it centered. So we'll start off with planar. Top of the platform we know is going to get parallel in line with that. Solve, make sure the rest of the assembly is doing all right. In this case, I'm okay with this because one of the next pieces that we're going to use is actually going to be the parallel mate. So parallel, we want this edge, okay, forward edge, to be parallel to the monkey bar itself. Okay, so we'll try solving that, seeing if that works. And what that's going to let us do is we're able to go ahead and deal with some of those distances. Okay, so we can actually tell it what offset we want in this circumstance. So I'm going to go ahead and come back to that one in a minute. The last one, the planar mate, we know we need to have these edges touching this edge of the playground. Okay. So we can solve, we can go ahead and check, that seems to be working right. And then we can go back and we can actually change the dimensional distance. Okay. So where that's going 82 inches across, going past the platform, we can actually now tell it that that's only go 18 inches. Okay. One of the details in the technical drawings tells us that that is now going to go ahead and pretty much center the monkey bars to that platform. Okay. So, as before, go ahead, save a current version. We know that that's going to go ahead and hold us in place. Let's see, and that monkey bar, again, that 18 inches, okay. May make sense to go ahead and lock that in place in other ways, but knowing those distances is going to be a good starting point. So, next up, in terms of our files, let's go ahead and start dealing with let's go ahead and do the tunnel slide. Okay. So, let's place the part. It's going to be a little bit backwards from what we actually want, but we can go ahead and start applying the constraints and let it go ahead and do the work for us. Okay. So again, our planar tool, I think that's one of the main constraints that I'm using for a lot of this. We can tell it to go ahead and snap in place, change the direction. Okay. Now keep in mind, once you've got it kind of like where you've glued them together, you still need to take care of other orientations. So give it some guidance. It's not quite as intuitive as Autodesk Inventor can be. So we've gone ahead, put that in place. We now need to go ahead and take care of a couple of other factors. So like the monkey bars, we want it to be centered. So with the dimensions that we provided, grabbing a far edge and that to go ahead and solve. Okay. And let's see. Set that to 18 inches as well. Okay. Hit OK. And then what's left, okay, we can look from the top view and we can see that that's centered. But as you notice, it's still a little separated from where it should be. So for here, let's go ahead and change up to, let's see, I think the fastened is going to help me out the most. Okay, we'll go ahead and grab the bottom edge and then we'll tie it to the bottom edge. Okay, this is a little bit more powerful of a constraint, but as we solve that, we should now be able to go ahead and hit escape, clear out the tools. Notice we can click and drag, it's not moving. Okay. So once again, save the file, save the version, and then we're going to go ahead and install, or at least input the last of the main components with the spiral slide. Okay. Now, from what I was working with earlier, I think the spiral slide is going to be one of the more challenging ones to go ahead and get everything to line up. So where we will start is the same way we've kind of started before. Okay, we'll grab the planar mate. We'll tell it that I want it to go ahead and connect from that flat edge of the upper platform to rotate around until I can see it, to kind of the front lip of the top. Okay, so solve. It looks to be holding into position. We'll go ahead and lock it in there. But what's that's leaving us with? Okay, we escape out of the constraint. We've got a lot of movements that we can still do. Okay, now we look from different angles. We can see we can move it back and forth, up and down from that orientation. And we can't move it left or right from that orientation, so that first constraint we put in is doing its job. But we can also see that we're moving up and down. Okay? Now, just because of some of the difficulties I've been having with this, what I've been doing is I'm actually using the Fastener Mate, okay, because it allows me a little bit more control in terms of the offset. Okay? So we're going to go ahead and grab that. We're going to tell it to go ahead and constrain to there. Okay? And then I'm doing a couple of things. Now, one of them is in the Word document. Okay? When we go down to that, okay, we can see that it tells us that the offset from that top edge to the platform itself needs to be 10 inches. Okay? So offset, pay attention to your orientations. We know that that's going to be 10 inches. Okay? But then I'm going to switch to the top view, and we know that we don't want the slide to be going ahead and rolling through that platform. So we're going to go ahead and change our X dimension. Okay? And we'll say, let's try it at 7 inches and see what happens. Okay? So that's obviously going in the direction we don't want. Change it to a negative value. Okay? We're getting closer. Okay? But I had to go ahead and play around with this some. I think I ultimately settled on 8.5 inches is enough to go ahead and give us that clearance, so it's not going to be affecting that. We'll go back to a regular view, look at three-dimensionally, and having that solved. Okay, I think that is now pretty much holding in place where we want it. Okay, notice, click and drag, it's not moving. So, as always, save the work, make sure you're keeping track of it. And then what's left is we've got, let's see. What's left is we need to go ahead and start inserting the Crayon Pulls to go ahead and add some safety to this. So what I'm doing, going back, grabbing the usual parts. In this case, we know that we need the Crayon Pull. We want the surface of it. Okay? And I'm actually going to place several of these. Actually, we'll just start with one. Okay? So make sure that it's good. And this is where I'm going to go ahead and use the fastener constraint to go ahead and help us put it in the corners where we need those pulls to be at. Okay? So going in, grabbing kind of the center of the bottom hole, or the bottom surface, and then I'm going to go ahead and reference it to the corner of the platform. Okay? So from there, I can go into the top view, I can edit the offset, and when we go into that Word document, we know that we need to get it 4 inches in both axes. Okay? So we pay attention to X, so -4 inches to shift it to the left, and then 4 inches to go ahead and get it centered on the right. Okay? When we look at our isometric view, we can see that it's in line because that Z-axis, the bottom of that pull and the top of the platform are fitting together. So before I start doing some copying of it, okay, before I start using some of the duplicate tools. I'm going to go ahead and copy this. So right click, copy surface 1, since that's the file name for it, and then I can go ahead and start placing a few of those just by pasting it. Okay. So what we need is one in that corner, one in that corner. We'll need one along that edge, and one is there. Okay. So we still have to add 1, 2, 3, 4 of these. Okay. So alright, so I'm going to go ahead and apply the same constraints. We're using the fastener to go ahead and grab the bottom of the pull, go back to an ISO, place it in a top corner, okay. Set the offset, paying attention to your axes. So in this case, we need -4 inches, -4 inches to go ahead and put it in position. Okay. Checks out. We can go on to the next one. So mate, pressing M to go ahead and use a shortcut. And again, keeping track of kind of the offsets that we need. In this case, X needs to be 4, Y is -4. Okay. We can solve it. Looks good. We're able to go ahead and move forward to the next one. Okay. So grab the mate, grab the bottom, hit the corner, and check your offset. Okay. In this case, X is -4, Y is 4, okay, and we're able to go ahead and move forward. Okay. Last one, grab the bottom, switch up, and change the rotation a little bit so I can get to that corner. Okay. And then using top, again, pay attention to your orientation and your directions. For the offset, -4 and -4. Okay. So with pulls placed in each of the corners, okay, this is where we can go ahead and start using the assembly patterns, okay, to go ahead and set the directions. Okay. So I grab it. The instance is the first object we want. Direction, I'm going to go ahead and use the lines that are already created. According to the documentation, we need 7.5 inches of spacing between the pulls. We can change the direction, and I'd say let's try 3 pulls at that location. Okay. That looks good. And then we're basically repeating the process along all of the axes that we're going to care about. Okay. So that same pull that I just grabbed, grabbing the pattern again, direction, changing the axes. You can use the top view to help see how far it actually needs to go, but 7.5 inches, and I should 3 to go ahead and max that out.
A few moments later.
Kind of continue the process. We can go ahead and grab a pull, tell it that we're doing a pattern, set a direction, 7.5, and I'm going to go ahead and copy that so I can go ahead and just paste it in the future. 3 in that direction. Okay. Same pull, same pattern. We can go ahead and set the direction and paste the distance, and then let's say 3. How does that look? Okay. Yeah, I think that'll work. Now you can actually do some of this from the top view as well. Okay, you know you're grabbing an instance of the surface. You can set the direction, change it as needed, and 3. Okay. Now the downside to this is it's very hard to go ahead and kind of repeat it across all of the platforms, all of the pieces. But as we get down to it, okay, we know that we've got an instance here. we can go ahead and grab the pattern, and it works along diagonal distances as well. Okay? So, and if I remember right, 8 looks good. Again, some of this is kind of playing around and guessing your way through it. But as you can see, we've now been able to go ahead and take care of the full assembly. Okay? So definitely be mindful of the variations between the different mate constraints. They are a little bit different than the documentation covers. OnShape, I think, is a little bit more finicky. And obviously you can see that there are a couple of errors that I'm going to have to address later on. But do your best to go ahead and work your way through the assembly process, and when you can, copy and paste instances of the different parts and use the assembly patterns to go ahead and help make it a little easier, save you some of the same steps. So, best of luck, and as you need help, certainly let me know. This is definitely one of the more challenging parts of this project, but once you've got that, you're pretty much done, and the only things left are small details like trying to add color or texture to the parts. So, best of luck, and like I said, let me know if you need help.